Okay guys, back again. I just needed to check. I understand it's cutting the top of my head off, but I suppose that's a good thing really. You don't want to see my face, do you? You'd rather see the board. That's what we're here for, guys. Okay, so I'm going to, exactly where I finished off on the last one, I'm going to rub this out and I'm going to use this graph, if I can, to put this spectrum, to use the correct terminology, to put a different one on. It's a bit tricky rubbing out on this, but there you go. Okay, let's make that line nice and smooth. Alright, okay. Right, so that was your first one. Propan 1-hole, 3 different environments, job done. Let's have a look at another one. Okay, let's have a look at this. Now this illustrates something. Propan 2-hole. Maybe I'll be better off over here. Propan 2. Oh, different beast this. Let's have a look at it. COH, CH3, CH3. Okay, now let's have a look at these environments here, shall we? Oh yes, right. What have you got? Environment 1. Hang on a minute. Those are exactly the same as those methyl group joined to that carbon there. There's symmetry in the molecule. There's symmetry. That's a key word. So 1 and 1. The one there, 2. So where does that lead us? No problem. If we look, chemical shift, that's the sign for chemical shift, a sort of Greek delta thing. Chemical shift for 1 and 1. Just call them 1. That's a CC. CC. So that'll be somewhere between, well, I don't know, 0 to 40, say. Chemical shift for number 2. Oh no. So CC. Chemical shift for number 2, different ball game. That's between, say, 50 and 90 because it's CO. So, different place. Let's just quickly show you the sheet. Here it is. CO, CC. Exactly the same. Okay, unlike the previous one where there were subtle differences. So, in other words, job done. Number 1, 0 to 40. We'll have that here. There's your CC. Number 1. That carbon and that carbon, identical chemical shift. This is chemical shift at the bottom. I should have labelled that up. That's very important. Okay, chemical shift, and it's in parts per million. Okay, right. So that's cool. Number 1. And CO, 50 to 90. There, CO, number 2. That's your carbon 13 NMR spectrum for, carbon 13 NMR spectrum for propan 2-hole. 1, 1, 2. 1, 1, 2. Sorted. 2 different environments. Okay, next. The more I do of these, the more idea you'll have. So get rid. Do a few of these. Now these are, like I keep saying, in the pack, and you will be expected to have a go at them and complete the pack. Then give it a week, you can get the mark scheme forward. That's the plan. Okay, right. Ethylamine now. What the hell is ethylamine? We all know what ethylamine is. CH3, CH2, NH2. Sorted. Okay, so what's going on with that? No problem. Should have drawn the bonds out really, but you should be able to see, you go into red, there you've got a CC and a CN. CC environment, 2 carbons, 2 different environments. 1 CC, 1 CN. consult your data sheet. You should know by now. CC 0 to 40, chemical shift. CN, I don't know, CN, let's have a look. CN, oh, bit of an overlap maybe, but there you go. 30 to 75. Okay, 30 to 70, call it. 30 to 70, chemical shift, no problem. So that, number 1, number 2, number 1, CN, number 2. So, dead easy, 0 to 40, CC. 60 to, 30 to 70, okay, higher up, let's merge on that one, beautiful, there you are, CC, number 1, CN, number 2. Two different environments, sorted, ethylamine. I'm just going to rack through these. Alright, another one, bit of a beast now. Okay, but these are fine. You just have to identify how many environments there are and work off that. Okay. And look for, I've got a lovely question anyway to show you about symmetry and identical environments. Okay. Maybe a good way of doing that now, just altering what I've got in front of me, I want the lid for that, right, is this. Propanone. Environments. Where are we? Well, bit like propan 2. Environment 1, there ain't no difference. There's a line of symmetry, if you will, across that molecule there, and that's what you're looking for. But there's a C double bond O, definitely a second environment. So on this one, CC, number 1, CC, number 2, C double bond O. Chemical shift, CC, usual, I don't know, 0 to 40-ish, don't really matter. C double bond O is quite way up here, between 160 and 220. Wow. So, two environments. 1, because they're equivalent, symmetrical, whatever you want to call it. 2, C double bond O, who cares? Have it up here. Doesn't really matter. Somewhere between 100, no, too low. Somewhere between 160, which I've missed, and chemical shift, whatever. So C double bond O, proton, carbon 13 there. There you go, CC, environment number 1 there. Dead easy. Right, we'll do a few of these. Let's have a beast, I reckon. Well, let's just do a couple more and then I'll show you another video about equivalence. Classic piece of kit. Oh, dropped absorption out. What a silly Billy I am, eh? Right, anyway. Let's have a look at this one. Butanone. Right, butanone. Okay, so not the same symmetry in the molecule, plus there's an extra, that's butanone right there. What we're talking here, environment wise, go to red. Environment 1, but is it the same as that? No, there's no line of symmetry down that molecule, doesn't look the same, no problem. 1, CC. 2, that carbon there, similar, same chemical shift, but not identical. 2. 3, again, not the same, very similar, but not the same, no symmetry. 4, definitely different. So there it gives you 3 close environments, but not identical environments, okay? Because they're obviously not. So, if we look at the tack on this, Do the easy one. Chemical shift for number 4. C double bond O. I don't know. 160 to 220. Chemical shift, absorption, that should say. 1. CC. Sure. CC. 0 to 50. 2. CC. 0 to 50, but not quite the same. 3. And don't want anybody saying, but these look the same. They're not the same, right? Look at the propanone one if you don't understand what I'm saying to you. That one there, number 3, CC again. 0 to 50. So you're going to get a cluster. Okay, a bit of a cluster. Somewhere between 0 and 60. Now, it doesn't really matter exactly where they are. It's not, but I've got them down here. I'm not sure I've got this information, but I need to deal with 1, 2 and 3. And number 4 will come up here. So number 4, C double bond O, chemical shift, whatever. Look at your data sheet, right? And the other 3, 0 to 50. Is that what they are? Close enough. Yeah, 0 to 50, smack on. So, whatever, doesn't really matter. I think that you don't need to know that level of detail. CC, number 1. CC, number 2. CC, number 3. 1, 2, 3. C double bond O, environment number 4. Carbon 13 spectrum for butanone. One more. And then I'll knock it on the head for this vid. Get rid. Okay. Last one. Ethyl ethanoate. That looks like a good one to me. What's going on here? Ethyl ethanoate, CH3, C double bond O, single bond O, ethyl ethanoate, CH2, CH3. Okay guys, still with me? Right, environment wise. Red. No matter which ones you call which, but here we go. Let's go from this end. Environment number 1, CC in there. There's a CC, of course there is. Environment number 1. Environment number 2. So, C, let's collect these. CC, 0 to 50 chemical shift. You know what, let's do the line straight away. Environment number 1, a CC. Okay, environment number 2. I made a mistake on here. C double bond C, single bond O. Right, certainly is. C joined to an O. Ethyl ethanoate, an ester. I made a mistake on my sheet. Now C double CO. Where's that to? 50 to 90. According to the sheet, 50 to 90. Environment number 2. 50 to 90. C single bond O, job done. Then C double bond O, C single bond O. Now that's tricky. C double bond O's up here, C single bond O is down here. I don't know because it's joined to both that carbon, but it don't really matter because we'll just, what matters is that carbon there, number 3, will have a chemical shift way out of it up here somewhere. So somewhere between, say, 50 right up to 220. So we'll say that one, we'll say this is the dominant one, it doesn't matter. We'll stick it at, say, 160. Well out the way. Okay, between those two, if you can see what I'm doing, there and there. So 160 I'm saying, yeah, because that'll perhaps drag it down a bit, that end. So C double bond O, different environment. And finally, a boring old CC, number 4. So 1, 2, 3, chemical shift values, 4, there, C, C. Okay, 4, job done. Again, 0 to 50. So, let's put these on our lovely spectrum. Number 1, number 2, CO. Number 3, we sort of said about 160, C double bond O and a C single bond O. So about there. Okay, so C double bond O, C single bond O. And number 4, well, who knows, but it's a CC, it's a CC. So number 4, CC. 4 different environments, no symmetry in the molecule whatsoever, 4 different environments, that's the way it is. Okay guys, thank you. We'll stop there and then I'll show you some symmetry things in the next video if that's all right.